Okay, so today we're going to go through 7.1, solving trig equations using inverses. Day 1 notes. For these notes, you should take out your unit circle, and so that you can use it to do the problems on the front. And so we will use the unit circle to find answers. For these problems, we will do example 2 on the front and then example 3 on the back, using the idea of the function and an inverse function. So remember that when I have inverses, the function and its inverse are where the domain and the range switch. So a relation that maps each element of the domain to only one element in the range is a function. And then an inverse function relates each element from the range of the original function to only one element in the domain of the original function. For our 3 basic trig functions, sine, cosine, and tangent, the inverse functions are written in 2 ways, kind of depending on what you see and what your calculator might say. So this sine, remember that -1 power is denoting that something's an inverse. So you could see sine with the -1 power on your calculator, or you might see the word arcsine. Same thing with each of them. So tangent to the -1 power is the inverse, or it could be arctangent. Cosine with the -1 power denotes that it's an inverse, or you could see the word arccosine. So arcsine of x equals theta means that sine of theta equals x, and we want to find theta. And then for arctangent, it means that we want to find theta when tangent is equal to x. So each of these trig functions have specific domain restrictions, and so the value for theta can only be within certain ranges. So for sine and tangent, that has to be between -90, which if we think about the unit circle, -90 degrees is there, and +90, which is here, or it needs to be between the radian equivalence, which is -pi/2 and +pi/2. And so what that means is that an answer for a problem that's asking me for sine inverse or cosine inverse, I'm actually just looking at quadrants 1 and 4. So it's not looking at quadrant 2 or quadrant 3 because that's not in the domain. Similarly, with inverse cosine, if I'm looking at a cosine function, so that first one was just for sine and tangent, the domain for the theta is between 0 and 180, so 0 to 180 degrees. Or if I'm thinking about that in terms of radians, from 0 to pi radians, tells us that in a cosine inverse equation, I'm only looking from 0 to 180, so only quadrants 1 and 2. Okay, so dependent on which trig functions inverse I'm using, that tells me where I'm looking on the unit circle. So we'll also use today, if we remember, the idea of all students take calculus to identify which quadrant we're in, right? So we'll automatically eliminate 2 quadrants based on what trig function we're given in the problem. So I just kind of rewrote what we have written at the definition. So if in example 2a, they want us to find inverse sine of 1/2. So if I set that equal to theta, that means that sine of theta equals 1/2, and we want to figure out what theta is. And so the first thing that we want to think about is what quadrant we should look. Okay. So if we think to what we remember from the patterns, all students take calculus, I know that since it's sine, I automatically can't look at quadrant 2 and at quadrant 3 because sine only goes between negative 90 degrees and positive 90 degrees. And so what I'm thinking about then is the idea that I have sine is positive here. So I only have two options. I have quadrant 1 or I have quadrant 4. And so sine is positive in quadrant 1. So that means that my answer is going to lie in quadrant 1. Okay, so what I'm looking at is in quadrant 1, where is sine equal to positive 1/2? So the other thing that I have to think about is the fact that this is a sine function tells me that I'm looking at the y coordinate on the unit circle. So I'm looking in quadrant 1 at the unit circle. Where is y? Positive 1/2. Okay, so if I'm looking at the unit circle only in quadrant 1, where is y? Positive 1/2. Okay, and so that's at 30 degrees and at pi over 6. So what that means is that my answer for this problem is that theta equals 30 degrees or pi over 6. Okay, so I'm answering both in degrees and radians after looking at the appropriate quadrant on the unit circle. So if we think about the next problem, this is saying we want cosine of theta to be equal to radical 2 over 2. So if I think about all students take calculus again, all the trig functions are positive in quadrant 1. Sine is positive in quadrant 2, tangent's positive in quadrant 3, cosine's positive in quadrant 4. For cosine, I'm only allowed to look between 0 and 180. So I'm ignoring quadrants 3 and 4 just because I'm looking at a cosine function. So remember that what I want to look at next is that since cosine is a positive number, I have these two options. So I have all or sine is positive. So cosine fits in with the all. That tells me that I'm looking in quadrant 1. Okay, so once I figured out what quadrant, the fact that I have cosine now tells me that I want to look at the x coordinate on the unit circle. Okay, so I'm looking for a radical 2 over 2 in quadrant 1 for this problem. So I'm still looking at quadrant 1. My x coordinate is radical 2 over 2 at 45 degrees or pi over 4. Okay, so that means that our answer for part B is that theta equals 45 degrees or pi over 4 radians. So then for C, we've got inverse tangent of negative radical 3. So remember, this is asking us when is tangent of theta equal to negative root 3. And so if we think about the quadrants again, remember that tangent and sine have the same restrictions. So I'm not allowed to look in quadrant 2 and I'm not allowed to look in quadrant 3. That my answer only comes from quadrant 1 or quadrant 4. So then what I'm looking at next is the sine of this value. So since this is negative, my two options are this one where all of them are positive in quadrant 1 and cosine is positive in quadrant 4. Tangent then is negative only in quadrant 4 from what I'm left with. So I know that I have to work with this quadrant. So remember that when I'm looking at this quadrant, I'm thinking about it as going negative 90 degrees. So my answer needs to be between 0 degrees and negative 90 degrees in this quadrant. So if I look at my unit circle, what ends up is that I actually have two different options. So the way that tangent works is that I'm dividing y by x. So I have 2 points that have a radical 3 in them. And what I have to do is determine which one this is that gives me negative radical 3. So one thing to remember is that I'm looking at the negative angles. So if I'm going that way, 330 is actually negative 30 degrees, and 300 is actually negative 60 degrees. Okay, so those are my two options. So I have to actually do a little bit of work to figure out which one's correct. I'm going to sketch this down here just so that you have it as a reminder of what we looked at. So my one option is either negative 30 degrees, which has the point radical 3 over 2, comma, negative 1/2. Or it's going to be at negative 60 degrees, which has the point 1/2, comma, negative radical 3 over 2. So what I have to do is figure out which one gives me negative radical 3, because remember that tangent is y over x on the unit circle. Okay, so that means that I'm checking for negative 30 degrees. My y is negative 1/2 over the x is radical 3 over 2. So if I simplify this, that's going to give me negative 1 over radical 3, right, which is not negative radical 3. Okay, so that means that that's not the answer. So just to make sure that we're correct, let's look at the negative 60. And so that is negative radical 3 over 2 is the y, over 1/2 is the x. And so we can reduce the negative radical 3 over 2 since they share the denominator, and that gives us negative radical 3 over 1. And so that is negative radical 3. So that means that our answer is negative 60 degrees. Or in radians, 60 is pi over 3, so or negative pi over 3 radians. Okay, so tangent is a lot more complicated because we're dividing. And so we have to figure out which point in those quadrants gives us the value that divides to the answer instead of just being able to read the x and y coordinates on the unit circle. Okay, so the questions that are like example 2, those are the ones where we're using the unit circle and where we're using these restrictions. So the restrictions come from the fact that we had inverse sine in the problem, inverse cosine in the problem, inverse tangent in the problem. So we're given that. We are going to be using inverses to solve equations on the back. However, since the inverse is not given in the function, we don't have those restrictions. Okay, so I wrote that down so that if you want to copy that and remind yourself why we're not restricting to only 2 quadrants, we're going to use all of the quadrants in these problems, then that would be a good idea. Another clue for this, and this should be labeled example 3. I'm sorry, it says example A. When I have decimals, I'm going to use a calculator to get the values, and I need to make sure my calculator is in degree mode. So remember that when you have a scientific calculator, what you're looking at is a button that might say like DRG or something. So see how if I click this, it changes from degrees, radians to radians. And so you'll only ever use degrees or radians in this class. But in this case, everything is in degrees, and I know that because this says degrees. So the fact that this happens, what's gonna happen when we use the calculator is it's always gonna give us an acute angle as an answer. And so we will have to use the idea of reference angles to solve for problems. So I wanted to remind you of reference angles before we start to solve these. So I drew the little marks for us to remember here, so to talk about the formulas. Sorry, I don't know why I lost my train of thought. So a reference angle, remember, is always touching the x-axis. So if I want to find a positive angle, so an angle that looks like this with an arrow, in any quadrant and using a reference angle, we use a formula for each one. So in the first quadrant, theta is always just equal to x. So if my answer is in quadrant 1, it gives me a positive value, the calculator will give me the right answer. Okay. If it gives me a value in quadrant 1 and I need to find something in quadrant 2, remember that means that I would subtract x from 180 because it's x less degrees than 180, versus in quadrant 3, I would do 180 plus x. Okay, and then in quadrant 4, it's 360 minus x. The key is that x must be positive for this. So when I'm using a reference angle formula, I need to think about x as a positive value. Okay, so x is just a positive degree measure in a reference location. So we're still going to draw the quadrants and talk about all students take calculus to answer the questions. However, we're going to use a calculator to kind of start the problem. Okay, so what we're going to do is solve the problem using inverses. And so the first step is going to be for us to take the inverse of whatever trig function we have on both sides. So an inverse undoes itself, right? Or undoes its inverse. So if I take and I do cosine inverse of both sides, and I just had all that writing, so I'm kind of writing in a weird spot here because I wrote too large there. So I'm taking inverse cosine of cosine, and I'm taking inverse cosine of 0.55. So in that step, it's like I'm dividing by 2, right? And so I'm taking inverse cosine of both sides. That's how I get rid of cosine. Cosine's a function. I cannot divide by it. So I have to take its inverse in order to cancel it out. So cosine inverse of cosine cancels out the cosine so that this is just theta. So theta is equal to inverse cosine of 0.55. So now this looks like the problems that we were given on the front of the notes. However, we're doing things differently because 0.55 is nowhere to be seen on the unit circle, right? So that's why it looks different from what we saw here. So what we're going to do is we're going to calculate this. So if I go back to the calculator, and so I want inverse cosine. So I'm looking for inverse cosine. What you're probably going to have to do on your calculator is hit shift or second, whatever that is on yours. And then it should give you an inverse cosine. Oh, I'm sorry, this one works backwards. So for this calculator, I have to type in 0.55. Again, I'm in degrees. And then I'm going to do second cosine. So this gives me this big long decimal. So what I'm going to take from that is just the first decimal place, so 56.6 degrees. So that means that theta is about 56.6 degrees. And again, I just had to do that backwards because this is how the calculator works. Remember that if you can see what you're typing, if it doesn't disappear each time, you can hit second cosine, then 0.55. So you should know how your calculator works with sine and cosine at this point. Okay, so what I have to think about is where my answers will be. So I have the potential to have multiple answers. So in the quadrants, we know that all students take calculus, and this is a positive cosine. And so cosine is positive in the all quadrant and in the C quadrant. Okay, so that tells me that my answer needs to be 1 in quadrant 1, which if I look at this guy, this one's a quadrant 1 angle. So this tells me that one of my answers is this angle that's 56.6 degrees. Okay, so one of my angles is 56.6, sorry. I forgot to do squiggly because we're estimating 56.6 degrees. The other angle has to be in quadrant 4. So this is where the idea of a reference angle comes in. So if this is 56.6, then I'm using the reference angle formula for quadrant 4, where x is 56.6. So since I know that my other answer needs to be in quadrant 4, my other theta value is going to be 360 minus 56.6. Okay, so I will have two angles. This angle is this measure. So that measurement, if I do 360 minus 56.6, is about 303.4. Okay, so and 303.4 degrees. So we're using inverse of whatever function, trig function we're given. However, we have to think about which quadrant our answers are in order to find the second answer. So we should have two answers for each of these because we're not restricting the domain. Okay, so if I think about all students take calculus again, for this one, in this problem, I have a positive sign. And so sign is positive when they're all positive in quadrant 1, and when sign is positive in quadrant 2. So that means that my answer is going to be in quadrant 1, and that should be the one the calculator gives me. And then I'll have to use the reference angle formula for quadrant 2, which is the 180 minus x, to find that other value. Okay, so let's solve for sine by using its inverse. So theta is gonna be isolated using the inverse sine function on both sides because we have the regular sine function. Okay, so we're using the inverse of sine on both sides in order to isolate theta, because inverse sine of sine cancels, and we're left with just theta equals inverse sine of 0.95. So we're going to calculate and do 0.95, and then we're going to trigonometry, hitting second, which gives us our inverses, and I want inverse sine. So that gives me 71.8. Okay, so theta is about 71.8 degrees. Okay, so I'm checking, and 71.8, if I think about that, is in quadrant 1. So if I draw that angle, it's going to be something like that, is 71.8 degrees. Since it's also in quadrant 2, the angle would be a reference angle of 71.8. And so I have to do 180 minus the 71.8 in order to find that second angle. Okay, so my first answer is that theta equals about 71.8 degrees. But then in order to find my other answer in quadrant 2, I have to use the formula that theta will be about 180 minus 71.8 degrees, which gives us about 108.2 degrees. So, and 108.2. Okay, so since sine was positive, I knew it had to be in quadrants 1 and 2. So whatever the angle is in quadrant 1, that's also the reference angle in quadrant 2. And so the values for these were 71.8 and 108.2. Okay, so for the last one, we're looking at tangent. And so for the tangent function, we have a negative. So if we think about our quadrants to determine where our answer is going to be, so if all students take calculus and we have tangent equal to a negative, that means I don't want tangent to be positive. So tangent is positive in the all and in the tangent. So that means it's the other two. So in the sine and the cosine, right? When sine is positive, cosine is positive, that's when tangent's going to be negative. Okay, so I'm in quadrant 2 and I'm in quadrant 4. So in order to get tangent or theta by itself, let's take inverse tangent of both sides. So inverse tangent of tangent theta is equal to inverse tangent of negative 0.35. So that means that the tangents are going to cancel because they're inverses. So theta equals inverse tangent of negative 0.35. So if it's in quadrant 4 and if it's in quadrant 2, that means that we should get a value representing that and that. Okay. And so let's look at our calculator to see what value that is. So if we're calculating negative 0.35, and then this time we're doing second or shift tangent to get the inverse tangent function, that gives us a value for theta of negative 19, that'll round up to 3. So negative 19.3. So theta is about negative 19.3 degrees. So what happens here is they're technically giving us our quadrant 4 angle, but they're giving it to us as a negative angle. Okay? So that means that our reference angle is positive 19.3. So when I have the positive value in that quadrant, I'm doing the 360 minus that number. And then in quadrant 2, we're doing 180 minus that number, okay? So technically this is in quadrant 4. But in order to find the actual measure of the angle, so to go from here to here, we're gonna do theta is equal to 360 minus the 19.3. Okay, so we're taking it as a positive value to get that value, which is about 340.7 degrees. Okay, so our first answer for theta is 340.7. And then we're going to also find the value in quadrant 2. And so in quadrant 2, we're finding this angle here. And so we're taking 180 and subtracting 19.3. And so doing 180 minus 19.3 gives us about 160.7. Okay, so and about 160.7. Okay, so we do have to remember and use those reference angle formulas in order to find the values. Remember that if your calculator ever gives you a negative answer for theta, that you're using it as its absolute value to find using the reference angle formulas. Okay, so technically, I mean, we could think about it as though since it was the negative angle in quadrant 4, we could add 360 to get the positive coterminal, and it ends up being that same formula that we have there in green. So when you're doing your assignment today, the front is the example 2 problems, and then the back is the example 3 problems. And so my hint to number 14 is think about the graph if it was y equals cosine of x, and think about what that would look like to kind of help you formulate your answer for number 14 as to why there's no solution to that equation. Okay, so if you type that into your calculator, you should end up with some kind of error. So if you want to pause the video so that you guys can take pictures of the homework or just display it for the rest of class, that would be a good idea.